So here, we have what we call hertz, which is frequency, which means that it is cycle per second, which brings frequency, where that frequency is F. You know that F, how do we get frequency? When you have frequency is the number of periods per second. It is the number of periods per second. That's frequency. Where its unit is hertz, which is Hz. That's the unit of frequency. So that is a difference of AC and DC. But we are going to put much effort on alternating current because that's where we apply what? Complex numbers. So let us try to see other explanations. Then we proceed. So then alternating current problems, we have their capacitors, we have their inductors, and also resistance. You know that resistance is the opposition to the flow of current. So now there is V, you know that this is voltage, which is equal to VO, e power j omega t. And you know that from when you have e power I angle, you remember in the exponential form, for e power I angle, you know that this is cos angle plus I sine angle. I think you remember this one. So if you remember this, so which means that one will become V equal to VO into bracket cos omega t plus j sine omega t. Where this omega, you know that omega equal to 2 pi f. For this f is frequency. That f is what? Is the frequency of supply. So when you have this V equal to VO into bracket cos omega t plus I sine omega t, what will be the real part of this voltage? The real part of this V, the real part of V will be what? To be VO times cos omega t. Then imaginary part of V will be what? The imaginary part will be, it is the part which is the coefficient of this j. It will be VO sine omega t. Okay. This real part is called resistance. The real part is called what? Resistance. We call it resistance. Then the imaginary part, we call it reactance, which is this one. The imaginary part contains inductive and capacitive. It is either it contains inductive or capacitive. That is the imaginary part, which is VO sine omega t. So we have part A, where we have in the circuit, we have resistance and inductive. So when our circuit contains resistance and inductive, we have the equation which is V, because it contains resistance, which is, we have VR plus J VL. So now, you know that voltage, V, is the product of current. You know that voltage is directly proportional to the current. V, voltage is directly proportional to the current. So mean that when the voltage increases, the current also increases. So to remove this proportionality, we introduce a constant R. So now V is IR. So now our VR equal to current times resistance. So this is the resistance. R is resistance. And you know that resistance is the opposition to the flow of current. To the flow of what? Current. So now if VR equal to IR, so what is VR? This VR is current times inductance. Current times inductive reactance. So it is current times inductive reactance. This XL is inductive reactance. XL is inductive reactance. So how do we get XL? Our XL, which is inductive reactance, is equal to 2 pi FL. 2 pi FL. This XL, which is inductive reactance, is equal to 2 pi FL. Then its unit is ohm. It is ohm. It is ohms, the unit of inductive reactance. Even the unit of resistance, which is R, is what? Is ohm. Then we have seen that the resistance is the opposition to the flow of what? Of current. So now, from the formula where VR equal to IXL, XL is equal to 2 pi FL, then we know that we know that when you have voltage from the voltage which is equal to IR, you know that the voltage is what? IR, which is current times resistance. So now, how do we get the impedance? How can we get impedance? So, meaning that our voltage will be equal to current times Z. So this is VR. From VR equal to current times resistance. So now the voltage of the circuit will be equal to the current times the impedance. Because our current contains what? Impedance. Where this is Z, where Z is impedance. Our Z is impedance. So our Z will be the impedance. So now, we come back in this formula where we have V equal to VR plus J VL. So if our voltage is current times impedance, so current times the impedance will be equal to VR, which is current times resistance, plus J VL, which is VL is current times inductive reactance. So you see current is common. We take I out of the bracket. We remain with Z equal to I into bracket R plus J XL. We cancel current, this I cancels this I. We remain with Z, which is equal to R plus J XL. So meaning that our Z, which is impedance, its formula is R plus J XL. This is what we call impedance. This is the formula to get impedance. So when it is positive, it means that we have inductive reactance. When you find there is a positive here, that's to say you have inductive reactance. So when you find that you have negative, it means that you have capacitive reactance. That's what you're going to see. So let us go to see how we have negative here, which means that it will be capacitive reactance. Then we have, after getting the impedance, which is equal to the resistance, plus J, the inductive reactance, its unit, the unit of this Z, which is impedance, is ohms. It is ohms. So where this inductive reactance, its formula we have seen that is 2 pi FL. So what is L? L is inductance. And its unit is Henry. The unit of inductance is what? Henry, which is H. And if F, we have seen that F is the frequency. And we have seen that its unit of the frequency is Hertz. We have seen that one. So we are going to B, where we have reactance and capacitance. Reactance and resistance and capacitance. Where you have resistance and capacitance. So the formula, instead of we have seen that it was V equal to VO plus J VL. That's what we have seen. Now it's not V, it is not plus, it is minus. Where there is capacitance, it is what? Minus. It is VO minus J VC. It changes like this one. So we have the first one was V for we had resistance and reactance. For the resistance and the reactance, we had V equal to VO plus J VL. So now, for the resistance and the capacitance, it is V equal to VO minus, this VO is the same as VR, minus JVC. So where VR is current times the resistance. So VC is the current times inductive reactance, which is XC. Inductive reactance. So this is the capacitive reactance, which is C, which is XC, where VR is current times the resistance. So now, I'm going to fix this one in this formula. So we are going to have, and this V, capital V, its formula is the current times the impedance. So now we're going to fix this one in this formula. It will be IZ, which is equal to IR minus J IXC, which is capacitive reactance. You see I is common. We're going to take I out of the bracket. We remain with Z equal to R minus JXC. So this is our formula. So meaning that we are going to have Z, which is equal to R minus JXC. And the unit of this, what's the unit of this? It is ohm. Ohms. Then, so the difference, it will be negative and positive. It is negative when you have capacitive in the capacitive reactance. So, what is the unit? I have seen that XC is the capacitive reactance. So, what is the unit of XC? And what is C? XC is 1 over 2 pi F. That XC, which is this one, is 1 over 2 pi times frequency times C. C is the capacitance. Our C here is capacitance. And the unit of XC is its unit. Its unit is ohms, which is ohm. C is capacitance, and its unit is farad. The unit of capacitance is what? Farad. So let us see examples. We're going to see examples.